Thanks everybody for joining us. It's always nice to see people coming out, enjoying the webinars. This is the first part of a multi-part series that we're doing. So hopefully you'll be able to join us as we go along the way. We do record everything and everything goes on our website on our site and on YouTube. So if you do miss one, luckily you can go back and check some of those out as well. So this one today is really an introduction to what we call collection system flow and rainfall monitoring. So try and keep it kind of higher level. Today we're all going into the holiday break, so give us a bit to chew on, but also kind of prep and set it up for the future webinars as well. I mean, this is a fairly it's a fairly detailed program or topic that we could get into a lot of detail on. So there's probably a whole host of 20-30 episodes we could do on this, but we'll try and keep it to 5. We'll try and keep it to the most relevant and pertinent aspects of these things. But as always, if there's any questions or people want to have discussions outside of the webinar forum, feel free to reach out. Always happy to touch base and connect and chat. So as always, a few things to keep in mind. So the webinar is typically two parts: a presentation and then a sort of Q&A or discussion session. So you can always type. You should see a little sort of Q&A window at the bottom of your screen, so you can always type in things as we go. So during the presentation or after the presentation, and then we'll get to those at the end. And we've always put in polls, so asking questions a little bit more about yourselves. So keep an eye out for the polls as we go along, and you'll see them pop up, and please answer accordingly. A bit of an agenda, so I'll talk a little bit about Civica. Again, I think most people probably are fairly aware of us, but I'll do a little bit of an intro to Civica myself and some of the work that we do and where we kind of focus our efforts. And then really when I was thinking about an introduction to the topic, it's really trying to talk about sort of the 5 W's and 1 H of what it is that is a flow and rainfall monitoring program. Again, more at a sort of higher level today, but we'll try and go through and tackle some of these kind of key questions of these programs. And then, at the end, have a bit of a discussion and Q&A. Happy to stick on and for those of you that want to chat a bit further or ask some questions, happy to jump into those. So as mentioned, this is part of a larger sort of webinar series that we're doing specifically on flow monitoring or flow and rainfall monitoring. So next one's more around the technology and the operations and maintenance of one of these programs. Hoping to get some people from sort of the supply side, some of the folks that supply some of this equipment to join as well. So hopefully, over the next few weeks and month or so, we'll release a further schedule and we'll get into some details on the people that are hopefully going to join me for some of these. And then we'll talk about data quality, some of the analysis that can be done in the context of flow and rainfall data. Talking, further on part 4 on I&I, the role of flow monitoring and rainfall in I&I studies. And then finally, the 5th part along, collection system modeling, how we utilize this data and really use it in the context and how we think about using flow data and how we're going to set up a program for flow and rainfall monitoring with sort of that end use in mind, which would be for this particular case modeling. So this is the sort of outline of the series, and as we move through, and you'll see announcements from us over the coming weeks and months as to when these things are going to happen. A little bit about Civica. So we're located in Vaughan and in the GTA. Most of our work is in Southern Ontario and the GTA. Really, we do a lot of work in collection systems, in sanitary sewers, in storm sewer systems. And our goal really at the end of the day is to help build resilient communities during these periods of sort of rapid growth and changing climate by maximizing the use of existing infrastructure. Really, that's the core focus for us. We do get involved with, new infrastructure and building larger and bigger systems and adapting to the growing community that way. But really where a lot of our focus is how do we get the sort of most bang for buck out of our existing systems. So this is sort of all of the different services and activities that we provide on the side. We have a pretty big group now, so we have quite a few engineers and senior staff with 25 plus years of experience. I would consider us sort of inflow and infiltration I&I specialists. We do a lot of flow monitoring across, again, Southern Ontario, mostly GTA, and a lot of the analytics that are derived from those programs. We do a lot of sewer asset services, asset management services, whether that's going in, we physically going to sewer systems, collection systems, just a few pictures of our CCTV vehicle. We purchased a flushing truck this year as well, and then we have a group that does grouting in manholes. So just a bit of a snapshot on some of the work that we're doing on sort of the asset management side and the sort of sewer inspection and rehab side, master planning, basement and surface flood studies, water resources engineering. So just a bit of a high level overview of Civica and some of the work that we're doing. A little bit about myself. So I'm a project manager at Civica, and I'm also the VP of Business Development. I have over 8 years of sort of what we call flow monitoring and collection system experience. I have a master's in hydrology and an MBA. The MBA probably won't help me too much today, but hopefully the hydrology side of it does. I have background in both sort of the consulting side of the world and the municipal side. So I've worked for a municipality in the past. This collection systems committee, I just received note last week that I'm going to be one of the newer members of the WEO collection systems committee, so looking to get involved there. And I'm also currently on the WEO magazine committee. So that's a little bit about me. So for us, we want to typically ask this question is kind of get to know the audience. So you should see a poll pop up momentarily, and just love to hear a little bit more about you, what type of organization you work for, just so that we can get to know the audience a bit better. Give that a couple seconds. All right. So it looks like we have about 70 to 75% are from municipalities, one from a provincial government agency, a couple from consulting, and a couple from conservation authorities, which I'm not sure that we've had in the past. So welcome everybody. Hopefully this is engaging and you learned some stuff today. And again, as we move through the course of the webinars, hopefully we get to interact some more and learn more about each other. Okay, so going back to the agenda, talking about flow and rainfall monitoring. So what is it? What do we mean by rainfall monitoring, flow monitoring? So in the most basic sense, the act of measuring sort of a natural weather phenomenon. In the case of rainfall. So we're sort of subject to sort of forces outside of our control in terms of what happens in the communities that we live. The weather and the climate that we experience is really something that we, at least to the date, I mean, there are places where they're seeding clouds and causing rainfall, but it's something that we sort of are recipients of, we don't have a lot of control over. So we're really trying to understand what's happening to us from a sort of natural weather phenomenon perspective. That's on the rainfall side of things. When we're talking about flow monitoring, we're measuring flow, or we're measuring a response to inputs. So, when we talk about a collection system, when we're talking about wastewater systems or storm sewer systems, there's various inputs. We can call them human-derived inputs, whether that be sewage or some sort of effluent. I'm thinking of like a treatment plant that discharges to a river system or a lake-based system. And then we also have the natural inputs to those systems as well. So, maybe your storm sewers are dry 90% of the time, and they're only flowing when we do get rainfall or snow melt or things like that. Same with sanitary or wastewater systems. Ideally, they don't, take on too much of that natural input, but that does happen, and that really drives a lot of the work that we do. Is how do we mitigate some of the impacts of some of these natural inputs to our collection systems. So if we talk about those human impacts, again, on a sort of collection system, when we're talking about flow, this is sort of a typical flow pattern for a sanitary sewer system. So, this is kind of a repeatable diurnal pattern based on, let's say, land use type. So this is kind of the expectations. So over the course of the day, you may have a peak, and this is sort of 7, 8 a.m. in the morning when everybody's getting up, going to use the shower, the facilities. So you get a spike in the morning. So this is, day one. This is a Sunday, a Monday, a Tuesday. So every day you're getting sort of this repeatable pattern of human input to this collection system, and this is the resulting flow from the system. Maybe at night, so in the morning you have a peak typically, and then another peak at night when everybody's home from work, they're doing their dishes and using a lot of water. And so this is sort of your typical inputs from a sort of human induced or human input factor. And then at night everybody's in bed and nobody's using the water or the facilities, so very little water use. And so this is sort of the typical diurnal pattern and flow pattern that we see in a sewer system and a wastewater system anyways. So this is, just a graphic showing how transient some of these flows are. When we talk about a sort of a separated sewer system, when we're talking about storm sewers and wastewater systems, in dry weather, again, your storm sewers may be dry, they may not be flowing at all. And then your wastewater systems are just those inputs from that sort of human component or industrial component. And then when we have wet weather, that's when these things become active. That's when they're performing or hopefully performing as designed and as expected. And that's when you get your measurements, and that's when you're trying to assess what's happening within these systems, both during dry weather and during wet weather occasions. And that will be an assessment of how these systems are doing with respect to the inputs that are going into them. When we talk about why, so why are we doing this? Why do we care about flow and rainfall monitoring, and why do we run flow and rainfall monitoring programs? So, taking a step back, really, when we talk about collection systems, when we talk about storm systems, sanitary systems, combined systems, natural drainage channels, things like that, we have to kind of think about it as these are, and I heard a good presentation a couple of weeks ago, ultimately these are providing a service to, we'll call our clients, that we all represent, and everybody here, we typically represent the residents that live in the areas where we manage these systems that pay taxes. And do they, ultimately, do they value the collection system? So are they willing to put, dollars on the line or out of their pocket to help maintain and build out these systems? Are they doing the job that they were intended to do? And do they bring value to the residents? And I think that's sort of a good context to think of all the work that we do. is, what value is it bringing ultimately to the end user of that system? So I think we can sort of check that box for the most part. I think a lot of the work that we do in these collection systems, clearly having the ability to flush your toilet or turn on your taps and not worry about where that water goes is a clear value and a clear service to the people that we're doing this for. And same with, when it rains, if it's not, causing flooding on my property or on the road, then I'm happy, out of sight, out of mind. So there's certainly a lot of value there. So that's just one reason why we do the work we do, and we focus a lot of the effort that we do on understanding these systems and collecting this type of data. We want a greater understanding of this natural phenomena. So as I mentioned earlier, we're kind of subject to the whims of the weather and the climate that we have in our areas. So, understanding these patterns, long-term patterns, long-term effects of things like rainfall, what's happened in the past, how do we know it's going to happen in the future, is really helping us to kind of contextualize, how we plan to manage these systems. Ultimately, we all have to assess these systems. We'll call them built systems, infrastructure, how they're performing against, what we ultimately expect of them through design. So we have to understand, again, what those inputs are and how our systems are responding to those inputs. And maybe there's certain things that we didn't account for, and we need to understand those so that we can, manage and mitigate any sort of impacts from those inputs. And it gives us context for sort of level of service assessments. So level of service, and I have another slide or two here around that, is, how do we understand the value that we're bringing, and how do we make sure that we're doing as much as we can to reach that level of service? So, when you talk about a wastewater system, how do we make sure that we're providing the service up to the level that was expected and that's planned for, and how do we get it there if we're not there? And gives us some context for having some of those discussions. So when we talk about level of service, I mean, really it's impossible or nearly impossible to design and build a system to accept everything. So, if we have a 1,000-year storm or a 200-year storm, there's going to be flooding. So when we talk about providing that value to the resident, it really needs to be around, up to what level are we expected to provide that service, and what does it take? Where are our gaps, and what does it take to get us to close the gaps based on a common level of service that we've agreed to. So some of the considerations, specific to collection systems are around, how big of a storm do we want to accommodate? What is acceptable flooding? At one point, if we get a 200-year storm, is it acceptable to have flooding, and in what locations, and things like that. So these are the types of sort of considerations that go into a lot of these kind of level of service conversations. I just pulled an example from a municipality in the GTA. So, for storm sewers, they have a catch basin density such that sewer capacity is largely used during a 5-year storm, and overland flow cannot go beyond the public right of way during a 100-year storm. And this is, kind of a common, you'll see slightly different language and different levels of service between different municipalities, but this is sort of one that's fairly common to municipalities around here. So again, contextualizing what you're ultimately providing at the end of the day. And if you do have a 200-year storm, again, there may be flooding on private property because we've only anticipated and only designed these systems in this particular case to keep that flow, let's say, on the street in the public right of way up to a 100-year storm. When we talk about wastewater, one of the key ones that we do a lot of work with is I&I. So this is the newest sort of I&I allowance from the MACP design criteria, which was published this year, sort of an update as part of the CLI ECA regulations and updating the design criteria around that. So this is just one example. And you know, so this is 0.28 liters per second per hectare peak flow. And you know that there's no other sort of context to that. So when or under what sort of design storm, and I know some municipalities have gone to the level of saying, you know, we allow 0.28 under a 25-year design storm or under X, you know, situation. So it's providing that context and having sort of that target as to what you're going to do. If there, again, if in a particular system, if there's a 100-year storm, is it a reasonable expectation to have a 0.28 liters per second per hectare peak flow? Maybe it is, maybe that's the goal, maybe that's where the buy-in has got to get to that level of service, but that's the kind of context and the sort of rationale and target that a lot of municipalities need to work towards to or understand so that they know where, again, those gaps may be. So another poll that we decided was to see if you have a well-described level of service for your collection systems, or at least in your perception of the level of service for your collection systems. Do you feel like it's very well described and prescribed as to what those levels of service are, or do you think there's probably some room for improvement, or maybe you don't know, but just thought it'd be an interesting question to answer. So we'll give a couple more seconds for this one. All right, so it looks like we got a pretty good trend. There's a few people that are not really sure, which is fine. Majority, over 60% said somewhat. So it sounds like there's maybe some systems or one part of the system or another where there's a fairly well described level of service. One person said no. Two people said yes. So maybe at some point we could connect with those people and understand what kind of language and documentations out there for those systems. So really, at the end of the day, why do we do this? Why do we measure flow and rainfall? Really, when it comes down to it, it's sort of an asset management question. How many, and I put $5 signs, how many thousands, millions, billions of dollars in assets do we have? Does your municipality or jurisdiction have under management? Most municipalities are probably in the millions or billions. So how do we understand what's going on in those assets? It's not just going to be figured out through flow monitoring and rainfall monitoring. There's other activities that need to happen, but this is another sort of crucial and key piece of the puzzle to understand what's going on within those assets. From an operations and maintenance standpoint, how are these systems performing? How much flow is going through a particular pipe? Is that what you expect? Where are they underperforming? There's certain activities and certain insights you can get from flow monitoring activities, like where are blockages, where's I&I getting in? Are there things that we can do upstream of those systems to reduce from a sort of an operations and maintenance standpoint? The things that we can be doing on a regular basis to get some of that water out of the system or reduce blockages and things like that. And then ultimately, from a sort of planning perspective, how do we make these existing systems better and accommodate future growth and adapt to changes in climate? So, we have to understand what's going on in these systems now to be able to accommodate sort of future changes. And with a lot of the things going on in Southern Ontario, across Canada, there's a lot of growing municipalities. How do we get the most, again, going back to the start of the sort of presentation, how do we get the most out of the sort of finite and and expensive infrastructure that's already in the ground. So where? So this is an interesting question. Where in these systems do we do these activities? So I kind of have the sort of catch-all for both for rainfall and for flow monitoring. You try and distribute these activities or these measurements, well distributed across where you have these assets or infrastructure. I mean, this is specific to sort of collection systems, but there are other entities within, municipal organizations that will use rainfall data, not just for the purposes of the collection system, let's say, so transportation groups or asset management for buildings and things like that. They may also want access to some of this information, but generally, we try and distribute these measurement equipment across municipalities. Sort of rule of thumb is to have one rain gauge for every 5 to 10 square kilometers of sort of area within a municipality. Some municipalities are pretty small. They may not even be that size, but try to have at least a minimum of 2 rain gauges for small systems, just as a backup and to make sure that they're kind of corroborating what each rain gauge is saying. And then for flow monitoring, I mean, again, it can be, we go into a lot of detail on this, and I'm sure as we go through the next few webinar series around, with modeling in mind and I in mind, we'll talk a little bit about where we typically put flow meters. I mean, in the basic sense, we're trying to put them at least upstream of some of our critical wastewater infrastructure, so your treatment plants, your pumping stations, and then trying to distribute them across the system as much as possible. There are quite a few municipalities that we work with that have permanent monitoring locations. They've been in for 10, 15, 20 plus years. At sort of key locations, trunk sewers, pumping stations, treatment plants, things like that, that they'll use for multiple purposes. And then, a lot of those same municipalities will have, let's say, temporary monitoring for a whole other host of reasons. So when you're looking at I&I studies or trying to further delineate where I&I is getting into the system, model updates and calibration, again, that could be both on the sanitary and the stormwater side. There's quite a bit more focus, I would say, these days on stormwater systems, which is nice to see. It's been mostly quite a bit more focus on the wastewater in the past, but the stormwater is getting a bit more attention. Capacity assessments, looking at where that future growth is going to happen. Can these systems accommodate flows? Even bypassing for construction. So any capital program or construction program, you'll probably see when you need to do pipelining or pipe replacements, things like that, you'll have bypassing pumping that's required. And so you'll need to do some flow monitoring for that particular activity. So it just depends on, again, what the context of that flow monitoring is, but just some high level understanding of where flow monitoring happens in a lot of municipalities. So this was another poll that we decided to come up with was, from your flow monitoring program, do you have a permanent and a temporary flow monitoring program, or just a permanent, just temporary, or you don't have one at all, or you're not sure? So yeah, I'll give folks a couple seconds to answer that question. Great. So it looks like the majority have actually a permanent and a temporary monitoring. About 50% have both. 10% with just a permanent, 20% with just temporary. So that makes about sense. There's a few people not quite sure, but I think that makes sense based on the size of the municipalities that we have here today, and a lot of the bigger ones have kind of permanent sites, as I mentioned earlier, and kind of supplement that with some temporary. I know a lot of smaller municipalities have done a lot of temporary monitoring. They'll put in monitors across the system, once every 5 years for about a year, and leave them in and see what happens and take them all out. But it seems like a lot are moving towards at least having a few locations where there are critical infrastructure, to keep at least a few permanent ones in there. When do you do these activities? So this is an interesting one, and I know there's some folks that have joined from the West Coast, so it might be a little bit different over there. They don't typically get as much sort of frozen ground for as long as we do here, although I hear Vancouver's about to get some more snow, so good luck with that. But we've seen again a lot of those permanent flow monitoring locations, so they're in year-round, sort of 24/7, 365, and they will continue to be for the foreseeable future. We do see a lot of municipalities that have rain gauge networks that are operated throughout the course of the entire year. There are heated rain gauges. There are weighted rain gauges, and which are a little less common, but there is the ability to manage a program throughout the course of the year. Many of the sort of flow and rainfall programs that we've worked on focus particularly between sort of March, October, November, trying to save some costs over the winter months where we just mostly get snow and not a lot of rain. However, we have had some kind of recent rain on snow events, particularly if those folks around the GTA remember the sort of January 2020 event. I think it was like a 5 to 10 year storm. It was just rained all day, probably anywhere between 30 and 50 millimeters, something like that, on snow, and it caused a lot of issues within collection systems. So, and it seems like, there's quite a bit of rainfall and snow melt that can happen over this time period. So we generally recommend to continue monitoring through the winter, but it does depend on the sort of nature of the work that we're doing, and what sort of the budget and reason the municipality has to want to do some of this monitoring. The good thing about monitoring over longer sort of time periods is the ability to look at seasonal analysis and performance of these systems over different seasons. So a lot of municipalities like to install, February, March, and get the sort of spring melt and see what the impact of spring melt is on groundwater and the wastewater systems. We like to do a lot of reporting around, sort of your springtime, summertime, fall, and you can see in some areas, not everywhere, but in some municipalities, there's clear flow pattern differentiation between those different types of years. So, higher spring flows, a lot more groundwater influence, and then larger maybe storms in the summertime. So what's happening in the summer when you get these high intensity rainfall events and things like that. So it's a nice way to kind of look at the data and kind of see what patterns there are based on sort of the weather and the climate during different times of the year. So it's kind of like, you can do it all year, you can do it for parts of the year, but to get a true sense of what's going on, if you want to understand it at a system-wide level, or you have critical infrastructure that you're trying to understand what's happening upstream, you can do these programs over basically the whole course of the entire year. And then how? So I won't go into too much detail on this, on some of the equipment. I do want to touch on it a little bit, just because it kind of gives us the background for some of the future webinars that we're looking to do. So for rainfall monitoring, we typically install rain gauges. So these are two rain gauges, actually at a wastewater treatment plant. They asked us to do two in this case, just for redundancy. But basically you want sort of open ground. You don't want trees overhanging because then you're not getting an actual sense of what's happening. You don't want any, yes, you don't want any sort of vertical obstructions. There are definitely some good resources online on how to site your rain gauges, different levels of sort of accuracy and setups that you can go to get the highest level of accuracy, having things like wind baffles, and various ways to set it up to get to certain quality levels of rainfall data. But in general, you want it to be open, no obstructions, easy access, try and minimize chances of vandalism, things like that. You can get bird guards, so you can stick them on top so birds don't sit on it and cause you issues. But these are some of the sort of high level recommendations and ways that you want to set up a rain gauge. So typically when we're doing rainfall monitoring, and this is common across probably most Southern Ontario, across Canada, across the world, really, is using tipping bucket rain gauges. As I mentioned earlier, there are other types of rain gauges, like a weighted based rain gauge. But this is kind of the most common you'll see around Ontario, at least for measuring rainfall. So this is the top, on the top right, this is sort of looking down into the rain gauge. So it's basically just an orifice with some grates and filters to clear out and prevent any debris getting into it. If you remove the top, you'll kind of look down, you'll see this little kind of a siphon that collects the water and dumps it into this sort of seesaw apparatus. So this is the bottom of the rain gauge. So this is essentially a collection. It's like a little bucket at the bottom that collects rainwater, and as it gets to a certain point, it fills up enough, it tips over. It sends an electrical pulse to the logger, and it drains out, and then it just kind of goes back and forth like a seesaw. So this is typically how we measure rainfall. Most of the tipping buckets we use are measuring on 1/4 of a millimeter, so 0.25 millimeters. Every time 0.25 millimeters of rainfall comes and fills the bucket, it tips, and then fills up the other side and keeps going until the rainfall stops. So this is sort of your typical rain gauge, tipping bucket rain gauge. Pretty simple technology, but very accurate, and for at least for the purposes that we're using them for. When we talk about flow monitoring, this is a piece of kit that's installed in a sewer. There's a lot of considerations when we talk about collection system monitoring. I won't go through all of these at this moment. A lot of these we'll get into as we talk about the future webinars on the equipment itself and operation and maintenance of a flow and rainfall monitoring program. But there's quite a few things that we want to take into consideration when we're installing this equipment, and depending on the environment that we're using it in. When we're measuring flow in sewers, or in collection systems, there's a few things that we can do, and depending on the level of sort of accuracy and detail and the sort of ultimate end goal of that monitoring, we tend to measure a few different things, and in certain situations we might just measure the depth of flow. So this is a situation here. This is a logger typically up top, and then your sensors down below. So this would be something that you can just mount on the side of a manhole and look down, and it will measure the depth of the water or the depth of the flow in a pipe system, let's say. So these are sort of just measuring one sort of aspect of the flow, which is the depth. You can assume velocity if you do know the sort of pipe characteristics. If you know the slope of the pipes, the shape, and the material of the pipe, you can assume velocity. It's not it's not the most accurate way of doing it, but if you do want to get a sort of, and this is how much flow is going through, you can certainly do that with these types of sensors that just monitor depth of flow. It's good for certain situations if there's like really tough access to a particular site that you need to get some flow data for, or at least depth data for. These can be used in this situation when only an estimate of flow is needed. So if you're not really too concerned about getting high accuracy flow, if you're more concerned on depth, and that goes to the final point on overflows when you're monitoring a particular location that has overflows, SSOs, CSOs, alarming, things like that you it may be spilling into from a combined system into a storm system, or a wastewater system into a storm system. If you just want to know when certain things are being triggered, then a depth may be good enough for your application. It all depends again on what the sort of end goal of monitoring is. I did want to talk a little bit about open channels. When we're talking about culverts and ditches and things like that, we don't do this a lot. This is more for sort of riverine stream systems. We typically measure depth, so you can use a depth sensor like in the previous slide to measure from like a culvert or a bridge. Some conservation authorities have in-channel depth sensors, pressure sensors, or sometimes bubble sensors, things like that. So this is measuring the depth of water, and then we typically go out and measure sort of static or at a point in time velocity measurements. You can do that, during low flow conditions, at various flow conditions, up to, as high as you possibly can safely, ideally, to develop what we call a rating curve. And this will give you an understanding, as you develop this over time, the relationship between the depth and the flow at a particular point in a, let's say, a culvert or a river system. This is better for open channels. This is more, again, outside of the sewer systems that we do most of our work in, but just wanted to touch on the sort of open channel, sort of culvert, stream, ditch flow measurement as well. When we talk about, a more sort of highly accurate measurement of flow, particularly in sewer systems, this is where we get into area velocity meters. So this would be a typical setup. You have your logger up top, and then it connects down to the sensor in the pipe below. If we zoom in on the middle panel, this is your sort of typical setup. You have your band, your sort of mounting band, and then you have your sensor on the bottom of the pipe, and it has typically two different sensors. It will have a pressure depth sensor, so that's monitoring the pressure of the sort of water column on top of it, and that will give you a depth measurement. And then it also it has a separate sensor that shoots out sort of an acoustic pulse, and that will give you the velocity as the pulse comes back to the sensor, and measuring the speed at which it comes back, we'll get a velocity measurement of the flow. So you can convert this sort of depth using a pressure sensor, for example, to an area. So the depth of water, ideally you go down, you take measurements of the pipes or the shape and the size of the pipes, and we can convert that to an area of flow, a cross-sectional area of flow, and we can multiply that by the velocity of the flow that's coming through to get the overall flow. So your sort of area in, say, square meters by your velocity, which is meters per second, will give you cubic meters per second of flow. Oftentimes we convert that to liters per second, but you get the sense of where I'm going in terms of how we measure flows. Pretty much, this is one of the most accurate ways, or at least common ways of doing it. Here's one set up in the field. The sort of key benefits for these meters is they're relatively easy to install, and they're good for a lot of different flow conditions. The other kind of key important things, there's no or very little impact on the pipe capacity. So you can see there's a very thin band. The sensor's on the bottom of the flow. It doesn't take up a lot of space in the pipe, which is great. So you're not backing things up. And they work in surcharge conditions. So most of these sensors, they're still measuring velocity. A lot of them can record sort of negative velocities. So if the system backs up and the flow starts going the other way, and they can measure pressure, depth up to 3 to 5+ meters. So you can see when this system gets overflowed, you can see that in the data from a lot of these different types of AV sensors. Some other things, some other cool technology and sort of key really for us for technology for monitoring flows. One is a flume. So this is pretty sort of ancient technology in a lot of senses, but they've been used well over 100 years to monitor flows in wastewater systems using the kind of design that we have. So this is essentially using a flume inserted into the flow that constricts the flow, and the relationship between the depth and the flow is very well known for the dimensions of the flumes that we're building. So we would typically pair this. You'll see this is that area velocity meter. We'll still pair it with that so that it can work in higher flow conditions when the flume's overtopped. And we can also put in a depth sensor to measure the depth. And based on the relationship between the depth at that point behind the flume, we can get a very accurate measurement of flow in these systems. Here's a couple examples of those installed. We have a top right, we just have a sort of a stainless steel flume installed. We started actually 3D printing. Most of the ones that we're installing now are 3D printed, so we can get, customize them based on, go down, measure the pipe dimensions, and then get actual flume that fits very nicely into, because all the pipes they're supposed to be a certain size, but as anybody knows, if you go into these systems, that you can run into some situations where they're not exactly circular, or they're a bit smaller or a bit larger than you had originally anticipated. So yeah, these are high accuracy, high resolution, low head loss, and ideal for sort of low to medium flow conditions. As I said, once you get really high or surcharging in these situations, if the flow is going really high, it'll go above the flume, and then the relationship of depth and flow between the flume obviously falls apart at that point. And then finally, weirs. So these are very high accuracy, ultra high resolution. These are V-notch weirs. You can see this is in a newer subdivision, so barely any flow, really no flow through here at this point. Very sharp angle on the V-notch, but when there is flow and there's low flow, we can get very high accuracy measurements. This is the one on the bottom has a wider angle, so more flow is expected to go through this particular location. So these are ideal for those low flow conditions. We're doing a lot more flow monitoring in newer subdivisions, trying to see what the INI is like getting into the system before they're assumed. So these are great for that type of situation. They do require, frequent cleaning. The operation and maintenance of these are a bit more. So this is the sort of downside to putting a weir in, but again, great for these sort of low flow conditions. And finally, we'll talk about the who. So typically, this one I kind of left to the end, and it's a bit of a ball of wax because it does depend. It all depends. Responsibility that I've seen usually lies within a sort of operations group, sometimes an asset management or an infrastructure planning group at a municipality. Some municipalities aren't big enough to even have groups like that, public works groups. So it does depend. Some municipalities have fully dedicated flow monitoring programs and people that support those programs, and others do it as a sort of extra part of the daily sort of job that they have to do. In terms of equipment operation and maintenance, I would say the most sort of popular and prevalent is hiring a contractor to install and maintain and operate the equipment. There are some municipalities that do purchase their own equipment. There are some municipalities that do have their own staff that go in and do all the operation and maintenance of this equipment. Rain gauges is one thing. You don't need to have confined space entry, but for installing into storm sewers or sanitary sewers, you do need to have advanced training. So that's one of the reasons anyways why a lot of municipalities contract this out. And then when you talk about sort of the data delivery side, quality assurance, making sure the data is of highest quality and any sort of analysis that comes with that, that's typically, contracted out as well, contractor consultant that does a lot of that work. Some municipalities do have the sort of staff and ability to do some of that work themselves, but I would say typically that's sort of outsourced as well, to make sure that the QA/QC procedures are happening, that they're getting consistent quality data, and that any analysis that they want to do with that data is performed sort of outside of typical municipal folks that need to do it. Okay, so again, as I mentioned, we got the full flow monitoring series. We're going to release the schedule like early to mid-January on all the dates for the next 4 parts. We'll start to dig in a little bit more on some of the equipment, the data quality side, analysis stuff that's available, talk about I&I specifically and modeling, how these programs sort of influence ultimately a lot of the work that gets done from an I&I perspective and modeling perspective. So keep an eye out on for newsletters and our LinkedIn and everything to see when we schedule the next 4 parts for the webinar. What we always ask is, are you interested? I know quite a few folks have reached out in the past. We've been able to connect. And if you are interested in just chatting about your programs, Flow, Rainfall, again, we have some upcoming webinars. We're always trying to engage with folks. So if you do want to chat, feel free to answer yes or maybe, and we can connect probably after the Christmas break and see what we can do to chat about your program. And if not, again, feel free to join the future webinars. Hopefully you get some good information out of those as well. Okay. As I mentioned, all of our videos, all of the webinars that we do go up on our website, and you can just go through our website and they're all linked to videos on YouTube. So I think this is probably our 7th or 8th webinar that we've done. So there's some other topics. Feel free to browse and go on there and check them out. Always happy to see folks engaging with the content. And if there's any questions or comments, feel free to shoot me an email or shoot us an email through the website. We'll be happy to answer those. Just want to wish everybody very happy holidays. I hope everybody gets time to spend some time with their friends and loved ones. So season's greetings, happy holidays to everybody. Really appreciate everybody coming out and attending the webinar today. Yeah, it's been a fun year, so stay tuned for more fun in 2023. So with that, I'll say thank you, and I'll open the floor. If there's any comments, questions, feel free to write in the chat, put your hand up. I think we can pull you off mute and can answer questions that way as well. Let's see right here. So with that, thanks everybody. I think a couple minutes to 2, so I appreciate if some people got to leave, but yeah, feel free to stick around. We can stick around for a few more minutes. And again, happy holidays to everybody. Okay, so we have a few questions coming in. Can you comment on, Collins asks, can you comment on temperature monitoring? So I think most of our rain gauges, I'm trying to think, most of them have, especially if we're hooking up to a heater element, we don't want the heater on all the time. So they do measure temperature so that if it gets below a certain temperature that the heater can kick on. So that is one way to monitor temperature. I mean, there are pretty cost-effective temperature probes, temperature monitors that we can put out with rain gauges, for example, and connect to the same sort of loggers. We're doing quite a bit. We're doing some, at least from a data management standpoint, we're managing some of the meteorological data for Halton Conservation Authority. So we're bringing in like rainfall data, temperature, humidity, wind speed, wind direction. You can bring all that sort of time series data in pretty easily. And then from a flow perspective, most of the flow meters, at least the ones that have contact with the flow, so the area velocity meters that I talked about, most of the products we work with have temperature sensors in them as well. So it's kind of built in. So if you want to know the temperature of the flows, again, depending on what product you use, but a lot of them do have the ability, and it's sort of a standard feature of monitoring temperatures of the flows. So it is possible and pretty standard for a lot of equipment. We don't use the temperature, flow temperature data too much, but we're looking more and more into that, from an I&I perspective and other reasons as well. So I can go down the rabbit hole there, but I'll leave it at that for a minute. Are there any advances in I&I reduction that you can share? So I guess the easy answer to that is stay tuned for the webinar that we do specifically on I&I. There are quite a few advances in I&I reduction that are happening. Yeah, I mean, I'm sure we've done quite a few webinars, and we'll do more in the future on I&I reduction. So I'll leave it at that, but definitely if you want to connect after, we can do so. How large have you custom made the flume inserts? What pipe size? So I think we've done, I know in the past we've done some big pipes like 1200, I want to say, millimeter. We don't typically recommend too big, or we don't use flumes in a lot of large pipes. It is possible, but yeah, we've gone up to sort of 1200 millimeter, maybe a little bit bigger than that. Most of the applications that we're using the flumes are probably between 250 and 450, maybe 600 at the biggest for some of the flumes we have. We're just trying to, especially for those like trunk sewers and things like that, we try to put AVs in. We try and minimize any sort of backup or potential backup we can have in the system. Not that the flumes back up that much, but we're just trying not to put more into the flow than is necessary. We've also made some lower profile flumes recently. I have one that we're going to install in a project up near Blue Mountains. So I'll probably put that in the next webinar. I don't know if Sean's still there, but if you attend the next webinar, Sean, I think I'll put a slide in on that as well. There's a new piece of kit that we have. I don't even know that much about it, so I'm kind of speaking out of turn, but I'll look more into that and I can get back to you as well. Yeah, so that's the end of the questions. Again, thanks everybody for joining. I'll stick around for a couple more minutes, and if there's any other questions, I'll be sure to answer. And if you want to come off mute, feel free to put your hand up and we can chat as well. So Sean, there's a question about rain gauges on shortcut grass. Yeah, I mean, we do put quite a few rain gauges on roofs as well. It's typically easier for access, and it's tough to find a nice green space that's not like a park where people will go in and mess with your rain gauges. But roofs are actually, they're not great. The thing with roofs is that they're really susceptible to wind as well, which makes the monitoring of rainfall not as ideal. There's quite a few that I've seen as well where they put rain gauges kind of close to the edge of the roof, and there's a lot of wind shear that comes up off the side of the buildings, and it actually kind of blows the rainfall up and away from rain gauges. So if you do put them on roofs, do not put them close to the edge at all. That's one recommendation. But ideally, and if you look into some of the literature, and there's, you know, Environment Canada has some guidelines. There's another French one that I can send you as well, where they kind of they have like class 1 through I think 4 in terms of siting for rain gauges. So class 1's like best situation, best location, down to class 4. So yeah, ideally you're in a on the ground, sheltered, but with no sort of obstacles in the way. Anyways, I can certainly share some of that literature with you if you're interested. You know, for practical reasons, it's tough for some municipalities just to find a space like that. So roofs are, you know, often used, but not ideal for sure. All right, well, thanks everybody. I'm going to jump off, but you know, as always, feel free to shoot us an email, go through the website. There's a form you can fill out on there as well. If you have any questions, feel free to reach out to my email. Hopefully see you again in the new year, and have a great holiday season.